In this video, I'm going to explain everything you need to know about matrices as a beginner. Maybe the topic sounded confusing in class, or you just zoned out for a moment. Don't worry, I got you covered. I don't like a long intro, so let's get started. Let's start with the basics. A matrix is actually nothing more than a table of numbers. This table is made up of rows which are horizontal and columns which are vertical. Imagine a small table where the first row has the numbers 1, 2, and 3, and the second row has the numbers 4, 5, and 6. That is already a matrix. We usually describe the size of a matrix by how many rows and how many columns it has. For example, this matrix has 2 rows and 3 columns. So we say its dimensions are 2 by 3. And if we call this matrix, say, then we can write this as a to the power of 2 times 3. Note that we write it like that, but we don't read it like that. It's just a way of writing the size of the matrix in a compact form. Now, how do we point to one single element of a matrix? Let's say we want the number that is in the second row and the first column. We write this as the element A2, 1. In this matrix, element A2, 1 would be the number 4. Let's try a quick exercise together. Suppose we have a matrix B that looks like this. What are the dimensions of this matrix? The answer is 4 by 3. So we can write this as B to the power of 4 times 3. Now, let's talk about the types of matrices because there are a few. First, we have a row matrix. This is simply a matrix with only one row. For example, the row of numbers 1, 2, 3, 4. Second, we have a column matrix. This is the opposite. It only has one column, like a vertical list of numbers. Third, we have the diagonal matrix. This is a square matrix where every element outside the main diagonal is 0. The main diagonal runs from the top left corner to the bottom right corner. The elements on the main diagonal may also be 0, but this is not required. Here are 2 examples. Fourth, there is the unit matrix, also called the identity matrix. This is very special. It is a diagonal matrix, but on the diagonal, every entry is 1. Everywhere else, the entries are 0. For example, in a 3 by 3 identity matrix, the diagonal has the numbers 1, 1, and 1, and everything else is 0. What is special about the identity matrix is that when you multiply any matrix with it, the matrix stays exactly the same. But I'll explain it a bit further in the video. Fifth, there is the triangular matrix. This is a square matrix where everything below the diagonal or everything above the diagonal is 0. Here are again 2 examples. Sixth, we have the zero matrix, which is simply a matrix filled with only zeros. Wow, that was a lot of new information, but I hope and think it was at least somewhat self-explanatory. Let's look at operations with matrices because that is also possible. First, addition. If 2 matrices have the same dimensions, we can add them by simply adding the numbers in the same positions. For example, if we add the first row, first column element of matrix A to the first row, first column element of matrix B, we get the first row, first column element of the result. We can also do this with the second row and first column of the 2 matrices and with the rest of the rows and columns as well. So it is important to note that the 2 matrices have to be the same dimensions. Subtraction works the same way as addition. The 2 matrices need to have the same dimensions. If that's the case, we can just subtract the corresponding elements from each other. This is an easy example of a subtraction of 2 matrices, and the result is 0, 2, 5, 1. We can also multiply a matrix by a number, which we call a scalar. To do this, we just multiply every single entry in the matrix by that number. For example, if we multiply the matrix with entries 1, 2, 3, 4 by the number 2, then every entry doubles, and the result is 2, 4, 6, 8. Now let's talk about matrix multiplication. It does not work the same way as multiplying numbers or adding matrices because it is not done element by element. This is the hardest part for a beginner to understand, but I will walk you through it. To find one element of the product, we take a whole row from the first matrix and a whole column from the second matrix. Then we multiply the matching numbers from that row and column and add them all together. Now we will do it again for the first row of the first matrix and the second column of the second matrix. We again multiply the matching numbers with each other and take the sum of them afterwards. If you're confused where we place the elements in the product matrix, I'll explain it. We just look at which row and column we just used to calculate the number, and we place it in the product matrix with the corresponding row and column numbers. For example, if we take row 1 and column 1 of matrix AB, we place the value in row 1 and column 1 of the product matrix. If we finish the calculation, we get the values -2 and 3 in the second row of the product matrix. It is also important to note that the numbers of columns in your first matrix needs to match the number of rows in your second matrix. Otherwise, you can't calculate the product matrix. These rectangles always need to contain the same number of elements. And in this case, they don't. That's it for the basics you need to know about matrices. A big thank you to this viewer who left such a nice comment. If you have ideas for what you'd like to see next, feel free to share them in the comments as well. And if you enjoyed this video, I would appreciate it if you like this video and consider subscribing to the channel. I'll see you in the next video.